Hey partner, and welcome to a electrical rundown here by Mr. Yarber. Now in the background today we have, because we're reviewing electricity, our famous friend. I don't really know his name, and he's full of static, or not static, but just all kinds of electricity. Let's do a quick review and rundown of what electricity is. Now first off, we have two types of charges. We have positive charges, which are called protons, and we have negative charges, which are called electrons. Now when the two meet, boom, they cancel each other, okay? Now, what this means is whenever you have it canceling each other, what you have is called zero net charge. That means there's not a charge together. Like charges will actually repel each other. They send each other away. Unlike charges attract to each other, which is something that's pretty interesting, especially when we're talking about electricity. Only one type of mass all attract each other. Whenever you only have one type of mass, they all come together and attract each other. Now that's just a little bit of the background of electricity. Let's get into the major stuff, the meat and the potato. Watch out for that guy though. Y'all like my beard, it looks good. Now let's talk about this thing called static electricity. I wanted to give you some background on protons and electrons because that brings us to static electricity. We're all familiar, we've all taken a balloon and we've rubbed it and we put it on our hair and we see the static. Now here's the thing about static, the background behind static. A net charge of zero is neutral. That means there's nothing there. An object that is more negative is considered to have a net charge that is negative. An object that is more positive has a net charge that's positive. Whenever you have a tiny imbalance of the two, the charges cause these things known as static, which is basically two neutral objects that rub together to create some type of an electrical charge. Now, static, yes, we've seen the hair, and you can also rub your feet and go touch your buddy, and it'll give them a nice little pop. The reason it pops is because this thing called shock happens whenever an excess charge is strongly attracted to another. So it repels from that object and sends it to the next. That's where you get your shock, especially in a static electricity environment. Now, let's get to these things called circuits, okay? Circuits are pretty cool, and I've been in y'all's class and I've seen you work with them. Ms. Ziegler's awesome science students. These things called circuits, which is a complete path in which electricity can travel. Now we have different things. We have batteries, bulbs, resistors, motors, and switches. We have two different types of circuits. We have open circuits and closed circuits. Now open circuits is whenever you have a break in the path. A switch, for example, whenever you turn a switch off, you then have an open circuit. That means the circuit ain't complete. But a closed circuit actually causes things like light bulbs, sound machines, so on and so forth to come on. It allows them to come on, so you get the light. Okay, and I remember seeing y'all do the science experiment in there. Now, in order to get that light, though, you need this thing called current. Okay, current is measured in amps. And let's say that we're looking at a battery. Man, if I had a little battery here, I'd pull it out and show it to you. Whew, I'm hoping that joker don't electrocute me now. Now, a battery, the way it operates, the current or the flow of energy leaves the positive end of the battery, circulates and returns to the negative end of the battery. That's just our current. That's how it flows. That's how it operates. Positive to negative. Positive goes out, it attracts the negative. Voltage causes a current flow, which gives you positive energy, electron positive energy. Now, that brings us to another thing called resistance, especially whenever we talk about currents and we have electricity circulating positive to negative. Resistance measures how strong a wire or object can resist the current flowing through electricity. And that's one thing that we look at. We look at different resistance and stuff like that because that really measures how much electricity an object can take and cause things to power on and turn on. Now, we have this other thing called circuits. A circuit is the total amount of resistance in a circuit. It determines the amount of current in the circuit for a given voltage. Every device that uses electrical energy adds resistance to the circuit. So, for example, if you look at these pictures right here, okay, we have one light bulb here, which means that our resistance is not as, you're going to get a lot of power and flow going to this light bulb. Whenever we take it and we add 3 bulbs to it, the resistance decreases because it starts going onto the bulbs. That brings us to the next topic, conductors and insulators. Now a conductor, an example, silver, copper, gold, aluminum, iron. Conductors are those things that attract electricity. It brings electricity to it. Insulators, air, wood, glass, and rubber, absorb the electricity, so it prevents it from flowing through and passing through. Then that takes us into some other different types of circuits. We talked about major circuits a second ago. I'm sorry, I know I keep these videos 5 or less, but the problem is because this is a review video, it's taking a little bit longer. So, let's talk about a series circuit. In a series circuit, the same current flows through each resistor, but different voltage across each resistor. So a series circuit, for example, Christmas lights. Christmas lights, especially around this time, are a perfect example of series circuits, but you have your battery source here, the connection goes through, and you have multiple lights all in one closed circuit. That brings us to another thing called parallel circuits, where you have 2 or more paths of the current traveling through. In a parallel circuit, each resistor has the same voltage but different currents. So if we have a parallel circuit here, let's check out this picture right here. Okay, we have 3 bulbs, but notice we have 3 different circuits all running off 2 batteries. So that is a parallel circuit. This was a quick rundown on electricity. I know you guys have a test coming up, so I wanted to give you a quick rundown and background on electricity and introduce you to my buddy right here, Steve. I call him Steve the Runner, the electric bolt. I've enjoyed it. I hope you enjoyed it. Mr. Yarborough out.